Hello, everyone, and thank you for joining today's webinar, Introduction to Solid Edge. Please note that you have joined as an audience member and are muted. My name is Madeline, and I am today's moderator, and I'm joined by Dan Turk, application engineer and resident NX and Solid Edge guru, and Curtis, our director of technology, who will be joining us at the end for questions. We're going to go ahead and get started with a quick overview of our agenda. We'll begin with a little bit about Geometric Solutions, who we are, and how we can help you. Then we'll jump into our main topic, the basics of Solid Edge. Our presenter today, like I mentioned, is Dan Turk, application engineer at Geometric Solutions. Dan has had experience in a variety of industries in his 20 years, from automotive to consumer products to medical devices. He has really seen it all. He's an expert with NX and is rated as one of the elite 100 users in the world. He has taught NX at both small companies and Fortune 500 companies throughout the United States, Europe, and even the Far East. As far as a quick intro into who we are at Geometric Solutions, the Waltonen family is made up of 3 companies located throughout the Midwest: Waltonen Engineering, Independence Tooling, and Geometric Solutions. Our story is pretty simple. Waltonen develops innovative engineering solutions using Siemens software. We got so good at it, Geometric Solutions started selling the same potential for success in the form of Siemens software. So when it comes to implementing and optimizing these solutions like an expert, Geometric Solutions can get you there. In fact, nobody said it better than our president and owner, Lloyd Brown, that our ability to successfully partner with our customers comes from our experience using the tools we sell every day. And with that, I'll go ahead and pass things off to Dan. Dan, take it away.
Thanks, Madeline. So to start with, we're all here to talk about Solid Edge. Now, Solid Edge, it is a comprehensive and it is a powerful tool. You'll notice on the screen, you can see the pillars of Solid Edge. Everything from design, mechanical and electrical, to simulation, manufacturing, even being able to collaborate on the cloud. This is a very in-depth tool, and there's a lot of different ways in which you can use it. And so what I wanted us to do on this introduction to Solid Edge was to look at one of the specific tools within Solid Edge. I think you're going to like it. To start though, let's watch a little video that's kind of an introduction to Solid Edge. The thing we want to talk about with Solid Edge is synchronous technology. Now, you might think of synchronous technology as that's just a buzzword. Anytime you type in Solid Edge into Google, you'll see synchronous technology. And some folks will say it's phenomenal, others will say they don't like it. Well, let's take a look at the differences between history-based modeling and synchronous modeling. So history-based modeling, that's been around forever. That's been around for over 20 years. It's basically that you start with a sketch or you start with a primitive and then you start building off of that. And that's what we're used to in many different softwares. I just like to point out Solid Edge is very strong when it comes to history-based modeling, but we'll see what sets it apart. The nice thing about history-based modeling is you can have your models, they're driven by dimensions. They can be very highly automated. So if you think about a part family, having one part that creates multiple children, history-based modeling works great for that. And also you can have features. And the nice thing about a feature is you're able to go back and edit it. We've been using history-based modeling for so long that we kind of forget some of the negatives. And that is, it requires a lot of pre-planning. If you're a good modeler with history-based, you have to think, what do I put first? Because if you're wrong in the path you go, you might have to start all over. That's because history-based modeling, really, it's not that flexible. And then if you want to scale it and you have a lot of different features, well, you have some troubles there. So history-based modeling, there's the good, there's also a little bit of downside. The other form of modeling is called direct modeling. So this is where you have a solid model. So you can think about a 3D blob, and you start pushing and pulling on the faces, moving everything exactly where you want it. Now there's some positives. If you want to edit it, it's really easy. It's very flexible. Or if you have a part with a bunch of different features,
Hey, Dan, we lost your audio again.
if Curtis or Madeline, if you could tell me, I just had something pop up, audio connection.
Yes, you're coming in and out.
Oh, brother. Okay.
Now we hear you.
Well, we're going to have the other version of this as well, the on-demand, so you can pick up any pieces that I missed. Boy, today it just seems like it's one of those days. How much did we miss?
You got flexible editing done.
Oh, okay. I didn't miss too much then. So another nice thing about direct modeling is you can scale really easily, even if you have a bunch of features. And you can just pick a face, pick a surface, and directly interact with it. There's a lot of direct modelers out there. The downside, though, is that there's no features with most direct modelers. There's no dimensioning. It's literally just pushing and pulling, kind of putting your thumb up there, and that's what you're using to get the right dimensions or the right feel. And there's very little in the way of design automation. Well, this is where Solid Edge with synchronous technology comes into play. Because synchronous technology, it takes the best of history-based modeling, so having dimensions, having features, having relationships with our dimensions and faces, and the best of direct modeling, so being able to edit it very easily and having direct interaction. But then it leaves off the ugly bits, where you have to do a lot of pre-planning, or you don't have any dimensions. As I had mentioned earlier, Solid Edge is strong with history-based modeling, so you have that as an option, but we also have this synchronous technology, which is really a powerful option, a powerful tool. Let's take a look at an example of this. So what I've got here is I have just a simple part. And this is just a simple ordered part. And I want to just point out, I didn't go in and change anything on this. So you can see it's just a part for a electrical bracket. You'll notice that I have a history. So I started with a protrusion, then with a cutout, another protrusion, and so on. Let's just say, though, that I wanted to increase this gap by just 2 millimeters. And let's say that this is not a part that I've opened before, which is pretty common, I would say. So what do? I start to look at the part, click on each item, and figure out what made up that feature. So the first protrusion, I look at the sketch. Okay, nope, that's not it. So I'll look at the next item, the cutout. Okay, maybe that's what it is. So I'll edit the profile on that. And nope, that's just a cutout. Okay. So what it must be then is it must be this next protrusion, protrusion 2. So I'll go and edit the profile on that. Okay, perfect. So I can see that's the one that I want. Now it's kind of interesting. I opened this part up randomly. I had a bunch of models and I just randomly picked this one. What you'll notice is that this sketch is blue. Now in Solid Edge, when a sketch is fully constrained, it turns black, just like the other ones that you've seen. But this one, it's not fully constrained. I find that interesting because the whole point of using ordered modeling is that you would have everything completely constrained. And yet with this model that I haven't done anything to, you can see it's not constrained. It kind of defeats the whole purpose of what we're talking about. At any rate, I'm going to add a dimension, and I'm just going to bump this up 2 millimeters. So I'll change that to 3.88. And move that piece back into place and close. So we can see how our part, it did update, but we had to do some investigation on it. Now something else that's kind of interesting, when I changed that gap, it wasn't just the gap that changed. I'm going to do an undo. Keep your eye on these plugs. I'm going to do a redo. Undo. Redo. Do you notice what happened? You see, this just highlights some of the things you have to watch out for when it comes to ordered or history modeling. To start with, you should always have everything completely constrained. This released part that's being manufactured, it was not set up that way. The next thing you have to watch out for is, how is this piece interacting with others? We might think that there should be no interaction, or maybe there should be. You get the idea. Making a change with ordered modeling, it's not as simple as just keying in a few dimensions. Let's look at this exact same part. This time we're going to look at it in synchronous. So I've got the same exact part. And maybe I'll just do a fence select. Select this entire top, and I want to move it. So we said we wanted to move it an additional 2 millimeters. There we go. What's nice about this is we were able to choose what do we want to move, what don't we want to move. With synchronous technology, you could go in, we could add some dimensions, we could lock one piece to another. But I just wanted to show, to start with, that's a big difference between ordered and synchronous. In some of the videos that I'm going to show in just a moment, you're going to get to see that in greater detail. And the reason I wanted us to focus so much on synchronous is that's what separates Solid Edge from other softwares, is you have the ability to do both, but other softwares do not have the ability to do synchronous, whereas Solid Edge can do each. So Let's take a look at a couple of additional videos that are going to show us some different ways where synchronous can beat the competition. Now, the first one we're going to look at is rapid, let me expand my screen, rapid initial design. You've got a design, you've got something to start, and you want to get it done quickly. Let's see how solid edge with synchronous works. And then Curtis, if it goes out again, just if you could just text me. Actually, text me if it's good or bad. Let's give it a shot.
It's machined, cast, molded, sheet metal. Solid edge with synchronous technology allows you to create your parts as fast as you can think. We've just been briefed on a new spring clip that's needed, so let's throw this concept down. Starting from a blank space, we'll sketch a rectangle roughly the size we want and pull that into a sheet metal gauge. For a couple of flanges at either end, we can simply pull these out too. Let's do the same thing again to add a couple more flanges. And all the time, watch how we're working with our geometry rather than clicking through commands. Design is the focus here, not the software. Oh, and the design here should be for these flanges to angle out. No need for a delete or undo. We can use what we call the steering wheel, our main control in synchronous technology, to angle. But not both sides, I don't think. No problem, we'll just tell these faces to be at right angles. Just because we created these symmetrically doesn't mean there's history-based design intent tying us down, like you get in most any other CAD system. Easy. Okay, next up we need a guide for the USB block that this spring clip will hold. A bead would be ideal, and that's as easy as sketching a line where we want it to be, and then choose the size and shape of our bead. This one I used in a previous project should work just fine. Next, let's create a cutout to go through all three sections of the sheet metal on the right hand side. Oh, and check out this method as an even quicker way of sketching shapes. Nice. We'll centre that up, and although this is a concept, I do know this needs to be 16mm in width, so we'll tie that down. Another simple drag, this time to remove material, but we want this cut to be created before the part is bent into shape. No problem, solid edge can flatten the part on the fly before cutting. Very nice. For the retaining clip that we need, let's drag out a couple of flanges here and angle them both in. Same process as before, pull to create, and then the steering wheel to angle. We also need a sidewall to contain the connector block, so let's add another flange. But the material needs to be on the inside and a partial flange, not a full. Great. Along with the USB block, this spring clip needs to clamp a fuse holder. We'll pull out another partial flange, and then let's mirror this across to the other side. Oh, no, we've made a big mistake. The design brief clearly stated that this top sheet metal piece needs to be angled. I completely forgot. Remember that this was the first piece of geometry that we created. Everything else is built on this. But also remember, we're using solid edge with synchronous technology. Check this out. Steering wheel to the rescue, simple rotate, no drama. Let's get back to working on the clamp for the fuse holder. Remember we mirrored this, and notice along with everything else, this has been added to a feature tree. Yes, it's direct modelling, but there are still features to work with, like in history-based CAD. The best of both worlds with synchronous technology. That means we can edit the feature, breaking the link so that we can work independently on one side. And now we can add the jog that we want on this flange. Same process as the bead here, just a simple sketch line, and then apply the jog. Let's do the same for our retaining clip. Again, the same process, simple sketch line where we want this jog to be. And then apply that jog, dragging it out into position. Easy. Finishing up on our concept, let's get rid of some sharp edges by breaking corners. Nice and quick, click and go. And finally, we were briefed to include a hook to mount the whole spring clip. For this, let's push in the width of that second flange we created. And let me just repeat that, the second flange we created. No need to worry about the order that this was modelled, we're free to make this change. And then let's use a hem to create the hook. Choose the right size, and done. So in a short amount of time, we were able to throw down this pretty complex design working directly with the geometry rather than in and out of multiple CAD commands. And that's how it should be, no? Design the focus, not the software. And you'll be happy to know that even if you don't create sheet metal components like we had here, you'll still enjoy the same rapid workflow, minimal sketching, minimal mouse travel, easy push and pull modelling, and importantly, no need to worry about what order should I do this in. The flexibility to change your mind at any time. That's synchronous technology and Solid Edge. Design better.
Okay, so what we got to see there was the ability to make a new part and do it so quickly. Because it was with synchronous technology, if your first feature, the first thing you made, if you change your mind, no problem. Let's look at another example of this. What happens when you get an unexpected design change? Now, this never happens, right? We never get anything unexpected. No, we get it all the time. Check out how Solid Edge is able to accommodate this.
So we've received some markups of unexpected design changes for our tank. These have all come about from some late changes made to the mounting frame, and so we need to make some adjustments to accommodate. There are 4 changes to make. The first is to deepen a pocket 75mm for the hanger frame. The next, to bring face A in line with face B. After that, reduce the overall height of the tank to 425mm from the bottom. And finally, compensate for the loss of volume by angling this face out a further 15 degrees. Simple. For each change, we'll make the first revision as you would in most any other CAD system, working with the feature tree in a history-based approach. Then, we'll make exactly the same revision using synchronous technology. To help compare, we'll set a timer going in the top right. So, history-based approach first. Now, some of these traditional CAD systems do have direct editing techniques, so let's trial that type of tool for our first design change, editing this pocket. No good. Notice that this fails, assumingly due to some downstream features. So we'll need to go back to the history of the model and modify this feature itself. To save you falling asleep, we'll speed up the video where we can. This is taking time because as we edit the depth of the pocket, it's clear that another pocket is linked to match it. Design intent automation is usually seen as a good thing, but not when unexpected changes come about, as we have to find and remove that link. Okay, same change, but this time using synchronous technology. Timer restarted, and we'll go through this in real time because it's as simple as placing a dimension in 3D, entering the required value, and notice the other pocket is left well alone. Done. Back to a history-based approach for the second change, matching face A to face B. As we edit the top feature holding face A, because history-based CAD is order dependent, the cut below that holds face B doesn't yet exist, so we can't match to it. Therefore, we have to do some drag and drop reordering in the tree so that we can see what we want to match to. Oh, and notice some grey arrows that have just appeared in the tree. They're warning us that there's some kind of rebuild issue. We'll ignore these for now, but ultimately we need to come back and fix. The face angles need to match too, so we have to find the relevant feature and edit. This has had the effect of removing some rounds. Did we edit these rounds? No, but again, as one feature is delicately based on another in history-based CAD, often one change can turn into multiple changes. The clock is ticking. Let's take a look at how we'd make the same change in synchronous, including the draft. And don't blink or you'll miss this. 1 click, 2 clicks, done. History-based approach for the third change to reduce the overall height. We find which feature is the correct one to edit, usually not the most obvious one. A little bit more sketch work required for this change. Oh, and once again, some rounding to fix. Are you still following along? Does everything look okay? Are you sure everything rebuilt 100% correctly? This doesn't look like it used to do. Time for another fix, but good thing we spotted this before any molds were cut. Could have been costly. Using synchronous technology for that same change, we can make use of any reference dimensions that we place when we built this as a history-based model, but the difference is they'll actually control the geometry. Choose a dimension, enter the value, and let synchronous technology look after the rest. One last trip into the history-based approach. We need to increase the front angle 15 degrees to compensate for loss of internal volume from those other changes. Wait for the final rebuild, and wow, we have some big problems. There's a huge gap going through the middle of the part. The mounting holes in the top have also shifted, and some have even disappeared. Oh, and notice the red exclamation marks in the tree of failed features. We could spend many more minutes or hours attempting to fix this model. Or maybe it'd just be quicker to start again. And that same final change using synchronous technology, we use what we call the steering wheel for this, our main control in synchronous. We can use this to simply rotate around this round, and we can enter the precise value of 15 degrees. Done. All sorted, no rebuild issues. So, how did the times compare? 6 minutes 46 seconds for history-based, 1 minute 15 seconds for synchronous technology. That's over 6 times faster. Well, even more than that, in fact, because remember, our history-based model still requires work to fix. And it isn't just a time saver, it's a stress saver too. Keep in mind that this part wasn't modelled wrong, it's just that when design intent changes unexpectedly, issues can arise in history-based CAD. Solid Edge with synchronous technology means you can welcome unexpected design changes, even late in the design cycle. Meet your client's needs, improve your products. Solid Edge, design better.
I thought that was a really good video. I've worked on parts just like that, where it's somebody else's ordered part, and after a while you just give up and start from scratch. What they're really helping us to appreciate is that when you utilize synchronous technology, it can take someone that is not an expert with CAD, they're not an expert with sketching, they're not an expert with lining up faces and so on, and it makes them an expert because it's so easy to use. Let's look at another example. What about when you get imported 3D data from a vendor? Well, it comes in as a step, as an IGES. It's really just a big blob. What do you do then? Well, let's find out.
Today, we work in a multi-CAD world, challenged to import and often edit data, regardless of what software created it. Take this example, a chassis design where we need to import 3D supplier data from various sources and make edits where needed. First of all, let's take a look at importing the 3D data. Well, actually forget import. All we need to do in Solid Edge is simply open, like you would any other file. You can see here the many file types Solid Edge can open, files from other Siemens software such as NX, universal CAD formats such as Parasolid, STEP, IGES, and even files from other CAD systems such as Inventor, Pro Engineer or Creo, SolidWorks. SolidWorks. The first component we need to work on is from that system, so let's open that right up. Now it's easy to forget that this is a non-Solid Edge part, as we can work with it in exactly the same way we'd work with a native Solid Edge file. For example, specifying what material it's made out of to get the correct weight, or applying a colour or finish, nice and easy. Really though, the challenge comes when we want to make edits. Using a history-based approach like you would in most any other CAD system, you'd have to do some sort of feature recognition to dissect the model. That's not the case in Solid Edge with synchronous technology. All we do for edits is click on a face and drag. Simple and intuitive. And notice how things change sensibly. Other faces that are in line with this are moving too, just as if it was an original feature in a history tree. But what if you prefer editing existing dimensions instead? Well sure, just click a face and Solid Edge will provide a dimension for you on the fly, ready for you to edit. Again, notice the intelligence here of all of the holes changing as if part of a pattern feature. And if you want to add your own dimensions, you can do this in 3D, no need for sketch work. We'll add a dimension for this thickness, then reduce that to 6 millimeters. Notice the control we have in keeping that top face fixed. One good reason for having a history of features is when we need to reorder rounds. You can see here that the previous designer created 2 rounds in the correct order, but the other 2 are incorrect with the wrong blend. Can we solve that in Solid Edge without a history? Absolutely, just a simple right click to reorder. Done. while we're here, we need to make a change to the size of these rounds. By selecting one of these rounds, Solid Edge can automatically seek out other rounds in the model that are the same size. This way we can save a lot of time by making one edit, not multiple. In some cases though, you may want more than independent dimensions to edit, a good example being holes. Here we can let Solid Edge recognise these circular cuts as holes so that we can go in and change to a specific hole type. Here we want counterbores instead. But what about removing geometry? Well, that's as intuitive as deleting files in Windows. Simply fence select faces, or alternatively choose 1 by 1, and then just press delete. Solid Edge will look after the rest. So you can see how easy it is in Solid Edge to edit non-Solid Edge parts, very flexible. Let's speed through saving this and getting it roughly into our assembly so that we can move on to our next component. And this time we have a sheet metal bracket which was sent to us as a universal CAD file in Parasolid format. We can import this in exactly the same way as we did with the adapter. Remember, just a simple file open. Now, not only did we receive the 3D sheet metal file, but also its manufacturing drawing in .dwg format. Wouldn't it be great if we could make use of this drawing to assist us with any edits and also provide tolerance information, all in 3D? Well, check this out. Once we open the DWG inside Solid Edge, we can use a simple tool to grab the information we want just by fence selecting on screen, and then apply that information to our 3D model. Now you've already seen this steering wheel in action editing 3D geometry, and to keep things consistent, it can also be used for things like this, snapping drawing views into position over the model. So, nice to see the manufacturing intent overlaid in 3D, but wouldn't it be useful if we could control the model with these dimensions? Well, synchronous technology in Solid Edge can do just that. A simple click to attach, and these dimensions are now live, enabling us to make the required changes that we need whilst maintaining this manufacturing intent. For manufacture, we do need a flat pattern, but because this part wasn't created in Solid Edge, how are we supposed to produce this? Go back to the supplier? No, not a problem. We can tell Solid Edge to treat this as a true sheet metal part, flanges and all. Now we have an instant and accurate flat pattern. So let's speed through getting that bracket saved and into our multi-CAD assembly. And then finally, we'll bring in our drive motor. Now, when we bring this in, notice the file name at the bottom of the list on the left. Its prefix is INV. It's from software called Inventor. So like the other components we've been working with, this isn't a Solid Edge file either. After getting the motor in position, we can see we have a mounting issue. The two flanges don't quite match. Not a problem though. Synchronous technology in Solid Edge allows us to easily grab geometry sizing from one part and use it on another. Sorted. We obviously need to make more room for fastening hardware, so let's make some more quick edits here. First, let's increase the room between the motor and its flange. We'll add 20mm to the throat with a simple drag. And we need to change both parts together to add the required clearance over on the other side. Yes, that's right, a SolidWorks and Inventor part edited at the same time at the assembly level using the same simple push and pull that we used before. So there you have it, synchronous technology in Solid Edge, allowing you to work with non-Solid Edge data as if it was Solid Edge data. Importing just an open, editing just a push, pull or delete, and you can even make use of 2D drawings along the way. Solid Edge, design better.
So I think that what you're getting to see is just how powerful and how easy to use this software is. It's pretty cool that they were able to take a SolidWorks and an AutoCAD Inventor file and treat it like it's its own. And that's because we have that synchronous technology. Let's look at another example. We're going to talk about reusing designs we've already done. With Solid Edge, there's no need to keep on reinventing the wheel. No, you can use your designs again and again. Again, let's look at how we can do this.
Reuse and repurposing is of course the preference over recreation, whatever the subject. It saves time and effort. In CAD, this usually translates to importing data and working with the whole model. However, synchronous technology in Solid Edge also allows you to reuse individual design details. In this example, we're going to create a custom fuel adapter starting with a basic body and then simply reuse design details from other Solid Edge projects to complete. First, so that we know where our output ports are going to go, we'll quickly create a few holes. And notice how quick we can space these, no separate dimensioning tool required. Now for the barbs, and this is where we can save lots of time and effort. I know that we've created geometry like this before on another project, this blue component, so why not reuse this detail rather than waste time modelling from scratch? We simply select the detail we wish to use. The well-known Windows Pen Select saves a lot of time here. Oh, and notice that we're moving what we call the steering wheel to a specific position. This is our main control for synchronous technology, and here it'll help us locate the detail in our new part. Then simply click copy or use the Windows Control-C shortcut. Back in our custom fuel adapter, we just paste it in, again using the Windows shortcut Control-V if you like, and you can see our steering wheel is just where we left it, so placement becomes a simple task of snapping into place. And if you think you'll be using this detail again in the future, you can just store it away in the library. All you have to do is open your library pane and paste it into here instead. To reuse it, just drag and drop. The steering wheel can also be used to enter precise offset values. Here we'll offset it exactly 15 millimeters and then snap the barb into place. Additionally, by holding down the control key while we drag the steering wheel, we can copy this barb to the other location required. Again, notice the familiar use of Windows shortcuts. Holding control in Windows does the same thing, copies, quick and easy. Now that we have the barbs in the correct location, we need to figure out how we're going to attach the geometry to the part. Luckily, there's no need to worry about such things as Boolean operations, as Solid Edge will take care of this. Watch as it automatically extends to connect to the solid geometry. But what happens if we realise after pasting these barbs that we want to move them, perhaps to help hose clearance? No problem, we can use a steering wheel at any point in time to make required mods. Let's quickly add an angled offset here to the top and bottom connectors. Now that we have the output side of this fuel adapter finished, let's take a look at the fuel flow sensor side. Again, we have the basic geometry here. However, rather than modelling the internal sensor housing detail, let's also reuse this 3D detail from another project. The housing detail is already in our library, so all we need to do is drag and drop like before, and again, use a steering wheel for placement, this time ensuring central alignment. Notice that when reusing 3D detail, not only can features add geometry to parts, but they can also remove geometry at the same time. Furthermore, Solid Edge will also bring through design intelligence. For example, here the holes aren't just cylindrical pieces of geometry, they're real holes, so we can accurately modify them to suit. And as for this cutout, a key dimension has come through so we know to tweak for our requirements. Now that our custom fuel adapter is finished, let's complete the assembled unit by adding the sensor. Of course, here we're reusing a whole model rather than specific 3D detail, but still Solid Edge helps us out by reusing the assembling detail, its positioning references, to accelerate placement. In summary, we were able to precisely create our new component in just a couple of minutes, all thanks to synchronous technology in Solid Edge. It allowed us to easily reuse 3D detail from other models with just a simple copy and paste. And remember, this 3D design detail can be reused from not just Solid Edge files like we had here, but from non-Solid Edge CAD data too. Solid Edge, design better.
Again, the emphasis is on how easy this tool is to use. Well, let's take a look at it another way that we can use Solid Edge. We're going to look at one-shot multi-part editing. Now that's a mouthful to say, but it's pretty cool to watch.
Products are designed as a whole, not just individual components. This translates in CAD as the ability to easily edit parts at an assembly level. Here we have a Solid Edge assembly of a custom pulley system where we want to make changes to the width to fit a wider belt. Of course, this means editing several components. First, we'll approach this as you would in most any other CAD system, using history-based editing. Then, we'll take a look at how synchronous technology can help us out. So, history-based first, and let's start with the pulley itself for the initial edit. Notice the list on the left. This is the history-based recipe of features that make up this part. It can be tricky finding which feature is the one that we want to edit, However, Solid Edge does assist us by picking up the relevant feature after we click on the model in the graphics area. So let's take this 35mm dimension and change that to 55mm. Simple. Oh, no, wait. Because this is history-based editing, there are dependent features further down the tree on the left that this has caused issues with, damaging our model. So we need to go back and work out how we can make our desired width change another way. It turns out that we need to make multiple edits to not very obvious features in a particular order. Okay, done. So, back at the assembly level, obviously the wheel is now wider, which means it's interfering with the other components. And we have some internal parts to deal with too. Now, to modify these, we could continue using a history-based approach, editing each individual part. However, this is time-consuming, as you've seen. We could set up links between the parts so that a change in one part updates another. However, this too takes time. We want something instant that doesn't have the overhead of interlinking. So let's turn to synchronous technology. First, notice we're staying at the assembly level. From here, we can simply pick a face and drag to edit. And Solid Edge is intelligent enough to know that this is a symmetrical part, so we probably want to keep it as such. But ideally, we want to make several edits at the same time. Let's see how this works by selecting multiple faces from multiple parts. Here, we can modify not just one, or two, or even three, but let's edit 4, 5, and 6 different aspects from 4 individual parts. And still, Solid Edge is automatically seeing that this design is symmetrical, so actually it's doing double these edits for us. And also notice how everything else is changing sensibly. Tangent relations and wall thicknesses, for example, are all being maintained. That's what we mean by one-shot multi-part editing. Another way to make one-shot multi-part edits is by aligning faces, again, all at the assembly level. Let's take the back side of these brackets and align those together. Nice and easy, just click the first face from one part and the second face from the other part, and done. We could even take this a step further by asking Solid Edge to find all of those coplanar faces that we've just been working with, then get those snapped to this back face here. Just as easy, done. So there you have it. No more in and out of each part with multiple time-consuming history-based edits, or even the need to interlink. Synchronous technology in Solid Edge allows one-shot, multi-part editing, all at the assembly level. Solid Edge, design better.
So to me, that was probably the most impressive one. Having worked on parts just like that, where it might take a lot of time, it might take an hour, and yet with Solid Edge synchronous technology, we're able to do that really quickly. We're going to look at one last video that has to do with prepping our parts for simulation, because Solid Edge is also strong with simulation.
So we want to prepare a model for an efficient finite element analysis, but without having to be a skilled CAD modeler. Solid Edge with synchronous technology has some great, easy-to-use tools for this, whether the geometry is created in Solid Edge itself or not. In fact, the bracket we have here isn't a Solid Edge file, so first let's import it by simply opening it into Solid Edge. Well, that was easy. We can immediately see that there are a few aesthetic features. These don't play an important part in the structure of the component, so not worth analysing. Removing these will make it easier to mesh and speed up overall analysis, allowing computer power to be spent in more valuable ways. Now, unlike most other CAD systems, synchronous technology in Solid Edge doesn't rely on a delicate history tree, so removing features here won't cause rebuild issues. Most importantly though, it's very easy. First of all, the rounds. We'll ask Solid Edge to locate all of these for us and then simply delete. Next up, the spherical features and part number. This time a simple Windows pen select and again delete. Solid Edge looks after the rest. As we review the model, you'll notice that it is symmetrical, so simulating the whole thing isn't necessary. By dividing the model into quarters and only analysing one of these quarters downstream, we can achieve the results we need, but much quicker. After a simple sketch, synchronous technology allows us to use the regions created to simply cut away the quarters we don't want. Nice. Another area where we can afford to simplify is around these mounting holes. Selection Manager, the tool we used earlier to remove the rounds, is great for locating features in the model quickly. Here it can find the chamfers on both sides of these holes, making selection nice and easy, ready for a delete. Let's also remove this small hole, which is only a locate hole for another bracket. Notice every time we delete, Solid Edge patches the model up for you instantly. What about geometric edits you might want to make? You don't need a history tree for this, simply click on the face to drag and snap. The final preparation we'll do is in simplifying this top face. You can see that for some reason it has multiple patches, which may cause our simulation mesh to create unnecessary nodes and elements. Check this out. Solid Edge can take these 5 faces and turn them into one face instead. Nice and easy. So in a couple of minutes, without much modelling skill at all, we've used the power of synchronous technology in Solid Edge to prepare this model for an efficient simulation. Solid Edge, design better.
So there we got to see, even when it comes to taking apart and prepping it for simulation, with Solid Edge and with synchronous technology, it's easy to do. And that's the key, is the ease of use. We have a lot of customers that are using Solid Edge, and for many of them, they really struggled with CAD. Well, then we showed them the synchronous technology, and it was like their abilities, their speed, everything, it just enhanced greatly. And we're only talking about one small feature within Solid Edge, synchronous technology. We're going to have additional webinars, hopefully without the sound issues, but we're going to have some additional webinars that are going to talk about the other things you can do with Solid Edge, how it works within assemblies, how the drawings work, or a bunch of extra apps that you may never have knew existed. Let's close this off, and we're going to try and play another little video. We'll see if it works.
As an artist, you want to be able to make an impact on people's lives. And through this company, what we've been able to do is have that impact on thousands upon thousands of people. My name is Philip Vinson. I am the CEO of Mobile Glass Blowing Studios. When we started, we decided that we should figure out how to make a little portable glass studio that could be affordable to have, affordable to operate, and wouldn't require very extensive infrastructure, so you could move it easily. We went from a 12 by 32 shop in my partner's backyard, and now we have a 7,000 square foot facility and 12 employees in 3 years. I'm no longer the designer, the draftsman, the fabricator. I'm pretty much the person who runs the company. Because of our equipment, people are thinking about things in a different way. They're realizing that you don't have to have the big shop if you're not ready for it. They've also realized you can take the glass to the people instead of trying to get the people to the glass. We are revolutionizing the art glass industry in the world. There's no doubt about it. From the very beginning, I knew that I needed decent drawings to communicate the geometries involved with the designs of the furnaces. So I was using a fairly inexpensive CAD program. It was only 2-dimensional. As I moved further along, I would run into problems in the manufacturing, and it was very daunting to think I had to go back into that 2D software and fish around to try and even find what needed to get fixed. It was just such a waste of my time. So I knew I needed a change. I had used Solid Edge at a previous job, and I knew how powerful it was, and I knew that it could solve those problems for me. I came across the Solid Edge startup program, and I said, why not? Let's apply and give it a shot. And I was really thrilled when I was contacted, and it's made a tremendous impact in our manufacturing facility and our manufacturing abilities. One of the things that Solid Edge has allowed us to do is shave off a ton of time in the fabrication process, not only by creating very effective means of communication through very precise and concise drawings, but also allowing us to examine the ways that we fabricate things and the ways that we can put things together. All that has resulted in dropping our lead time. We were at 12 to 16 weeks for a unit to go out, and now we're hovering around 10, which is huge. If your quality improves, your communication improves, the workplace environment improves. You have very happy workers. They know exactly what's expected of them because it's on a good set of drawings. Solid Edge has really allowed us to move forward and become a more professional company.
Nice customer testimonial. I can do the CAD, although I don't think I can do the art that we were able to see there. But if you're interested in getting a trial of Solid Edge, please let us know. And what we can do is show you some of the tips and tricks that will help you to be really successful. Well, that's going to conclude our presentation. We only have a couple minutes. Curtis, do you have any questions?
Yes, sir. There's one here. Do I have to upgrade the premium platform to get this?
No, that's what's really cool about Solid Edge is you have a couple of different options, a couple of different packages, and even at the lowest level, that's what we're looking at, and that's what makes it so powerful.
If I've been trained here to do it parametrically, how long does it take to convert?
It's a great question. I've trained a number of our customers, and just about all of them, they were history based. Once they get their mind around the idea of not taking all that extra time, they just are off to the races. So frequently it's in day one of the class that we do that they're converted over and they're making synchronous modeling changes.
Cool. Those are the only two questions we had. Thank you
Great.
very much, and it was quite informative.